Okay, in this next example here, we have a function. It's a little bit more complicated. It involves 2 cosine over 2 plus sine over the interval 0 to 2 pi. So 2 cosine x over 2 plus sine x on the interval 0 to pi. So once again, we're going to begin the problem by finding our derivative. So as we find the derivative, I'm going to run through this pretty quickly, so you may, if you need to, pause it to kind of keep up, if you will. But I'm going to go through this pretty quickly here. It's a good one you might want to practice for the derivative. So here, using my product rule, I'm going to start off bottom 2 plus sine x times the derivative of the 2 cosine x. Remember, cosine's derivative is negative sine, so that'll be negative 2 sine x minus the top, the 2 cosine x, times the derivative of 2 plus sine x, which is just cosine x. Okay, so on the top I have 2 plus sine, negative 2 sine x, minus 2 cosine x, cosine x. That's all over the bottom function squared. 2 plus sine x, quantity squared. And now I want to do some simplifying. So I can take this negative 2 sine x and distribute it through to the 2 plus sine x. When I do that, I'll have negative 2 times 2 will give me negative 4 sine x. And then I'll have negative 2 sine x times the sine x will be minus 2 sine x squared. And then I still have cosine would be cosine squared, minus 2 cosine squared. Now, one of the parts I want to really focus on right here is this negative 2 sine squared minus 2 cosine squared piece. Okay, if you pull a negative 2 out of that, you'll have sine squared plus cosine squared, which every student's ever had some trig knows that is 1. So that minus 2 sine squared minus 2 cosine squared, pull the minus 2 out, we have sine squared plus cosine squared, which is 1, so we have negative 2 times 1, or just negative 2. So that leaves us with minus 4 sine x minus 2 all over 2 plus sine x squared. And then at this point, we're once again tasked with figuring out when is that derivative 0 and when is it undefined. This time we do have a denominator. A fraction with variables in it. So we do have to be concerned with, can that denominator be 0? So first things first, when is f prime equal to 0? When is f prime equal to 0? Well, that would happen when the numerator is 0, which would happen when negative 4 sine x minus 2 equals 0. So we need to solve that equation for sine x. So bring the 2 over, divide by the negative 4, we'll have sine x equals negative 1/2. Now to solve this problem, remember you need to figure out your reference angle. What angle in the first quadrant would give you a positive 1/2? Right? That's one of our exact values. What angle will give us a positive 1/2? Hopefully you're thinking of pi over 6. Now remember then, to solve that equation, which we're solving it across the interval 0 to 2 pi, so one full turn about the circle, we would need to take that reference angle of pi over 6 and draw it into the 2 quadrants where sine happens to be negative, which would be in the 3rd quadrant and in the 4th quadrant where sine is negative, because it's positive in both the 1st and 3rd. And so when you put that angle into the 2nd quadrant or 3rd quadrant as a reference angle, you get your pi over 6 past pi, which would become 7 pi over 6. And if you're in the 4th quadrant, your pi over 6 short of 2 pi, so it's 2 pi minus pi over 6, which would give us 11 pi over 6. And then we approach the question of, when is f prime undefined? Well, f prime would be undefined when 2 plus sine is 0. That would happen when sine is equal to negative 2. But we know that the range of the sine function, the standard sine function, is negative 1 to 1. Sine never gets bigger or smaller than 1 and positive 1 respectively. And so 2 plus sine x will never be equal to 0. So therefore, we're never dividing by 0, so f prime is never undefined. Okay, so now at this point we have two critical points. If you check the original function, neither one of those makes the denominator 0, so it is defined there. So two critical points, and we have our two endpoints 0 and 2 pi. So at this point we're going to turn around and plug those values into f to evaluate f. So we do that. F of 0 would be 2 cosine of 0, where cosine of 0 is 1, over 2 plus sine of 0. Remember, sine of 0 is 0. So we're going to have 2 over 2 plus 0, which would be 2 over 2, which is 1. And we do the same thing with the other two. We could get exact answers, but I'm just going to go with approximate answers here. So when I plug 7 pi over 6 in, I'm going to get the decimal negative 1.155. And when I plug 11 pi over 6 in, I'm going to get the decimal positive 1.155. And then finally, what is f of 2 pi? Well, cosine of 2 pi is a positive 1. Sine of 2 pi is 0 again. So we're going to have 2 over 2 plus 0, or 2 over 2. Turns out f of 2 pi is also 1. And so at this point, the largest value will be our maximum. The smallest value will be our minimum. And so you can see here we hit the maximum there at 11 pi over 6, right? The 1.155 is our max. And then our minimum would be that negative 1.155. Negative 1.155. That would be our minimum value. Okay, so that's what's going on here, our absolute max and our absolute min. So hopefully this will help you be able to follow the other examples in the notes and get you a good start on working through problems in the homework. And again, as always, if you find you have difficulty, please feel free to ask me if there's a particular problem you want to see done. Shoot an email to me, let me know, and I'll be happy to go over those things for you.